My hot take is that all ZK rollup teams are actually just rollup teams, and they should think of themselves as rollup teams, not ZK teams. With the technology we put out there in SP1, ZK has become a commodity. It is accessible to every single rollup team out there. And actually, recently, we did an integration with OP Stack, which is traditionally an optimistic rollup stack, and we made OP Stack into a ZK rollup. The integration is called OP Succinct, and it's like live and running, and people can use it. So if you want to prove some computation, you just write it in Rust, and then you can generate proofs with SP1.
Welcome to Epicenter, the show which talks about the technologies, projects, and people driving decentralization and the blockchain revolution. I'm Friederike Ernst, and today I'm speaking with Uma Roy, the co-founder and CEO of Succinct. Succinct are building a decentralized zkVM and prover network. And before we talk with Uma, let me tell you about our sponsors this week.
This episode is proudly brought to you by Gnosis, a collective dedicated to advancing a decentralized future. Gnosis leads innovation with Circles, Gnosis Pay, and Metri, reshaping open banking and money. With Hashi and Gnosis VPN, they're building a more resilient, privacy-focused internet. If you're looking for an L1 to launch your project, Gnosis Chain offers the same development environment as Ethereum with lower transaction fees. It's supported by over 200,000 validators, making Gnosis Chain a reliable and credibly neutral foundation for your applications. Gnosis DAO drives Gnosis governance, where every voice matters. Join the Gnosis community in the Gnosis DAO forum today. Deploy on the EVM-compatible Gnosis chain or secure the network with just one GNO and affordable hardware. Start your decentralization journey today at gnosis.io.
If you're looking to stake your crypto with confidence, look no further than Chorus One. More than 150,000 delegators, including institutions like BitGo, Pantera Capital, and Ledger, trust Chorus One with their assets. They support over 50 blockchains and are leaders in governance on networks like Cosmos, ensuring your stake is responsibly managed. Thanks to their advanced MEV research, you can also enjoy the highest staking rewards. You can stake directly from your preferred wallet, set up a white label node, restake your assets on EigenLayer or Symbiotic, or use their SDK for multi-chain staking in your app. Learn more at chorus.one and start staking today. Uma, thank you so much for coming on.
Thanks for having me.
Cool, Uma. Can you tell us a bit about your professional and educational background before starting Succinct?
So I've always done a lot of math. In high school and college, I did a lot of math research. And after school, during school, I studied math and computer science at MIT. And I also got my master's there, actually in machine learning. And after school, I was working in machine learning research at Google Brain. And then after was at a small startup doing machine learning stuff. But my interest in math is what originally hooked me into ZK. Because obviously it has a lot of math and it's a very math-heavy field. And I found ZK through a friend who I met at MIT. And that's kind of like how my background ties into ZK.
Your foray into kind of like blockchain was mostly prompted by your interest in zero-knowledge stuff?
Yeah, that's roughly correct. I'd always been interested in kind of like the ideas and concepts of blockchain broadly, not just ZK. But when I finally learned about ZK, that got my interest enough that I realized I wanted to build in the space.
What was it about zero-knowledge technology that kind of drew you in specifically?
Probably like a lot of other people, I was just really fascinated by the actual technology. I think ZK is a very magical concept. Like you can prove to someone else that a certain computation is true without revealing what the inputs are. That seems almost like it should be impossible. And so it was just a puzzle to me of figuring out how that's possible, understanding the math, understand the cryptography. And that's what really drew me in.
Cool. So you came for the tech. Tell us about how that kind of transformed into a vision for Succinct.
Yeah, so we were building in the ZK space for a while. So I met my co-founder at this summer residency hosted by Xerox PARC, which is this, I guess, sister organization to the EF, the Ethereum Foundation. And they were hosting this like kind of co-working over the summer together. So I met my co-founder there. We were working on a ZK project. Actually, it was related to Gnosis. And I think maybe that's one of the first times we interacted was through that. But we were building a ZK bridge from Ethereum to Gnosis chain, and in particular, building a Ethereum ZK-like client. So that was like our first foray into the ZK world, was building this project.
How did the product offering evolve over time?
So Succinct was started out of that project. So originally when we started Succinct, we were building a ZK bridge, kind of with this endgame thesis that the future of bridging was all going to be ZK-like clients. And I still think that's actually true. So we were really focused on building this bridge and making all bridges ZK. We worked on that for maybe like 6 months and actually shipped an Ethereum ZK-like client, and it got integrated into the Gnosis validator set as a ZK validator. We shipped a few other ZK-like clients. But then after some point, we realized that, ZK was too hard. Like building each of those like clients took, several months and many engineers. And it was very, very complicated. And we realized that, ZK has a lot of potential, but if it was always going to be so hard to use, it wasn't going to go anywhere. And that's what inspired us to build our zkVM SP1, which makes ZK really easy. So instead of spending months, making a light client and writing these like things called circuits, you just write normal code in Rust and you still can use ZK. And yeah, that was the evolution from our early days in ZK as like ZK builders to like building underlying ZK infra that makes ZK accessible to everyone.
Cool. Before we kind of dive into the zkVM, because I have so many questions as to this, let's kind of briefly clarify kind of what a ZK-like client does. So kind of like it's basically it's a client that can kind of verify the state of another blockchain on chain, right? So kind of can you talk about this a little bit and why you think ZK-like client bridges are kind of the end game of bridges?
Yeah, so a light client is just a protocol to verify the consensus of a particular chain. And so when you verify the consensus of a particular chain, you can then, understand if someone has like burned a token on that chain, and then you can mint them a token on the other side. So kind of like classical bridging. So a ZK-like client is just implementing that like client in a zero-knowledge proof and then verifying that proof on-chain instead of verifying like the whole like client functionality. And the reason you'd want to do this is if you want to run a like client on Ethereum, it'll be really, really expensive because you'll have to verify a bunch of signatures, you'll have to do a bunch of computation. Whereas if you have a ZK-like client, you just verify a proof of that computation. And that is just a lot more gas efficient. So basically, TLDR as a ZK-like client is a way to generate a zero-knowledge proof of a like client that makes it really gas efficient to use in on-chain contexts for bridging.
I think that's a fantastic summary. So kind of let's move on to the kind of zkVM part. So you said that kind of like building the circuits was really hard. How can we kind of like, as someone who's never actually written a circuit before, how do I go about it? So kind of I know what kind of the logic is I kind of want in that circuit. What do I do?
Yeah, so to take a computation that you want to generate a ZK proof for, you have to write it in a form that like you can actually do a ZK proof in. And historically, that meant taking your computation and breaking it down into additions and multiplications. So it's very primitive. You'd basically use a specialized language or a DSL. There's a bunch of other options out there, including tools like Circom, which maybe people have heard of, where you would make a computational graph out of adds and multiplies that express your computation. Obviously, that's it's not very fun because you're working with these very basic primitives and very basic building blocks, and it's similar to like writing assembly or writing a very, very low level language instead of writing something like Python.
Why is it that in order for it to kind of be incorporated into a ZK circuit, why can you only use additions and multiplications?
Yeah, that's a good question. So the way ZK protocols generally work is you take your computation and then you encode it into polynomials, and then you prove relationships between the polynomials. And that's kind of where the additions and multiplications come from. Like in polynomial world, you can do additions and multiplications, and you can prove that polynomials are related to each other by like those operations, I guess. Um, and so it has to do with like all the underlying math and cryptography of how ZK actually works, and kind of turning your computation into something that's polynomial friendly is the reason you have to break it down into these very like primitive um, relationships, if that makes sense. I mean, yeah, obviously there's a lot more math there that I could dive into, but maybe that's like a simplified explanation.
I think that's fair. Maybe we'll link to some resources in the show notes. So the zkVM, is my understanding correct that kind of I can put whatever Rust code or Python code or whatever into it, and it'll kind of automatically turn it into a ZK circuit?
So it is correct that you can put any Rust code into it. So now if you want to prove some computation, you just write it in Rust and then you can generate proofs with SP1. You can't do Python because like Python's like a
Yeah, fair.
interpreted language, but yeah, you can do Rust, which is like, I guess one of the most common languages used in blockchain. Um, it doesn't quite turn the code into a circuit. What it does is it compiles the code to an instruction set called RISC-V. So that's like similar to EVM. You have a bunch of opcodes, and then we prove the execution of that RISC-V, of all those RISC-V instructions. So we basically prove that like when you execute the program and all the instructions in the program correctly, that it gives like a certain output and a certain result. So we have a RISC-V circuit that is responsible for proving the execution of this RISC-V bytecode, and then your program gets run through that circuit, if that makes sense. So we're not turning your computation into a circuit. We're instead going through this RISC-V layer.
What's a RISC-V layer?
RISC-V is like an instruction set. So your program gets compiled to a bunch of instructions in a row. So it might be like do an add, do a multiply, do a subtract, then do a jump or do a branch or whatever. So that's like the underlying instructions of your program. And then we prove that like the instructions of your program are executed correctly, like in the correct order, and end up touching memory correctly and stuff like that, and having this final output. For those that are familiar with the EVM, it's very similar. Like you take Solidity, it gets compiled to EVM bytecode, which is a bunch of like EVM opcodes. And then when you run a smart contract, you're just executing a bunch of EVM opcodes in a row. So it's pretty similar mental model.
When you say we prove, who is we in this situation?
Yeah, like our zkVM SP1 is proving the execution of the RISC-V code.
Okay, cool. So it's a fully trustless setup, right? Kind of like
Yeah,
it's
yeah,
not
yeah.
you guys proving that. Okay, why hasn't this been done before? So kind of like it seems like kind of turning it seems like it's pretty well understood what kind of operations you can kind of feed into um uh a ZK proof. So why and I assume there's pretty good cookbooks how to kind of turn whatever you have into that. Why didn't what kind of you build exist before?
Yeah, it's a good question. Um, so I think for a long time, people were really fixated on proving the EVM. So there was a lot of ZK EVM teams. And I mean, that makes sense because validity and all the Ethereum stuff runs in EVM. So people are really fixated on that particular objective. And then I think also it wasn't super clear that proving RISC-V would be performant or doable. Like people thought it would be really slow. It's not an instruction set that's really designed for ZK. It's actually a very common instruction set that's used by, in many other contexts. So people just didn't think it'd be performant. They'd be like, sure, you could do this, but it would just be really slow. And I think one of SP1's major innovations was that we actually showed that it could be fast for workloads like clients or rollups that people care about. And now there's a lot of people trying to prove this RISC-V instruction set these days. And so these days there are more people trying to do that. I think it's worth mentioning two teams. One is the Starkware team. They didn't try to prove RISC-V, but they wrote a zkVM for Cairo, which is like their instruction set. And it's like it's an instruction set that's optimized for ZK or like designed for ZK. So they kind of like pioneered in many ways zkVMs way back, 5 years ago. And then the RISC-0 team was working on proving RISC-V execution. And then I think our major contribution was kind of taking RISC-V zkVMs and making them really, really performant for Rollup and showing that it's actually like practical to use for a lot of workloads people care about.
Cool. So I think kind of we've covered the basics of SP1. The other key part of your offering is the prover network, right? So tell us about that and kind of like how these two interact.
Yeah, so SP1 is, an open source project. You can run SP1 and generate proofs on your laptop. But I like to tell people that's not really a fun time because proof generation is very intensive. And so to actually make it very performant and really cheap, we have a GPU implementation of SP1 where if you generate proofs on a GPU, it's much faster, much cheaper. But obviously, I think most people don't want to like set up that infrastructure themselves. And so our prover network is a way for, anyone to outsource proof generation to the prover network. So instead of generating proofs on your laptop, you generate them through the prover network. So you send it like, hey, I have a program. Here's my inputs. I want you to generate a proof. And then the prover network provides a protocol for anyone in the world to plug in their GPU and contribute capacity. So it's kind of similar to mining, where like in the past, anyone in the world could, mine Bitcoin blocks through the proof of work mechanism. We have a similar kind of concept or architecture where anyone in the world can generate proofs and like earn transaction fees from the prover network.
How does the consensus mechanism for the prover network work?
That's like work that's coming out soon. So where right now the prover network doesn't exist. It's just like a concept we've put out there. But it's not actually like live or running yet. There's no consensus mechanism for the prover network. There's more like an allocation mechanism for like if there's a bunch of proofs coming in, who gets the right to generate the proof and earn the fees for that proof. So the allocation mechanism that we have is this like auction style mechanism that we're going to publish some more material on soon. And that's responsible for deciding like, who gets to generate the proof and at what clearing price the fees get paid.
What do you envisage as the use cases for SP1 and kind of the proofs generated by the prover network?
I think I'm really excited about zk-rollups in general. I think right now there's a lot of talk about the Ethereum fragmentation and all these problems that the rollups can't interoperate and talk to each other. And I think the biggest flaw of the optimistic rollup design is that withdrawals and bridging takes 7 days. And fundamentally, I think that leads to a lot of this fragmentation and interoperability issues. So I think ZK is the best way we're actually going to solve that in the Ethereum ecosystem. Every rollup, I think, will be a ZK rollup, and they will all be able to talk to each other via, verifying ZK proofs of each other's state. And then there will be like seamless bridging and interop. So in the near term, I'm most excited about ZK rollups using SP1 and turning every rollup into a ZK rollup. In the longer term, I think there's a lot of other really exciting applications even outside of blockchains. So for example, there's teams that are doing ZK email or ZK passport, where they basically prove, passport attestation information or email information in a zero knowledge proof. And then you can use that to bridge off-chain data on-chain, or you can kind of even use it in non-blockchain context to prove that like you have certain credentials or you're a certain nationality. And I think that's really interesting. Like basically ZK attestation, ZK identity is pretty exciting. And then there's a bunch of other types of software broadly that can be proven ZK that could benefit from verifiability that I'm also excited about.
So, talking about ZK rollups, I mean, one of the core tenets of kind of their existence is that they kind of produce these ZK proofs. I earlier kind of got the impression a little bit that this is infrastructure for customers of whatever feather that kind of are not specialized in ZK or kind of don't want to kind of put in the effort to kind of build their own ZK infrastructure. This can't be said for ZK rollups, right? So kind of like if you look at the ZK rollups that are currently out there, are they interested in kind of using a commoditized version of a ZK proof generator?
Surprisingly, yes. I think my hot take is that all ZK rollup teams are actually just rollup teams, and they should think of themselves as rollup teams, not ZK teams. I think with the technology we put out there in SP1, ZK has become a commodity. It is accessible to every single rollup team out there. And actually, recently we did an integration with OP Stack, which is traditionally an optimistic rollup stack, and we integrated. We took their state transition function, we stuck it in SP1, and we made OP Stack into a ZK rollup. The integration is called OP Succinct, and it's like live and running, and people can use it. So already we've kind of taken existing stacks that are non-ZK and integrated ZK into them. And so it's just inevitable that every single rollup will be ZK. So if you're a ZK rollup team, I think there's a lot to building a rollup that is very, very difficult and very important. That's not on the technology side. It's like BD, exchange integrations, making your ecosystem great, making your app developers' lives great. Attracting liquidity and stuff like that, attracting users. And I think now that all the rollups have ZK, I think all the rollups should like focus on basically like that more user-facing layer of the stack and just use whatever the easiest, best tool is for ZK, which in this case, like sticking, your rollup state transition function in SP1 seems like a pretty good option.
If you look at the proofs that ZK rollups use, are they in any way geared towards the use case? Because kind of SP1 is very general purpose, right? So kind of I would have assumed that kind of like if I were to build the ZK rollup, I would actually build it in such a way that it's geared exactly towards my purpose, and that would make it more performant than kind of a general purpose machine.
That's also, a really great question and observation. So I think historically that is what ZK rollup teams have done. They like hand coded this specialized custom circuit for the EVM and for their rollup. There's two interesting things though. One is actually SP1 is very, very performant. So we've actually seen it be sometimes even more performant than custom solutions that teams have created. And that's because a lot of these ZK rollup teams started a few years ago, and the ZK tech has improved a lot in the meantime. And also SP1 is really fast, and we have a GPU implementation, and we have this system of like precompiles that make it very, very efficient. So one surprising fact is that actually sometimes SP1 can be more performant than a custom stack for the EVM. And I think this was even surprising to us and surprising to other people. So that's like one interesting thing. The other thing is, even if SP1 is a bit slower, say it's even like, 50% or 25%, more expensive or slower, because you can just take normal code and run it in SP1, life in all other dimensions gets a lot better. So um, because you can just reuse existing Rust tooling like Ref and Revim and Ethereum node software, because your developers can update their state transition function whenever Ethereum upgrades. Because you kind of have like all this flexibility and you have really great tooling and it's so easy to build, I think the the benefits basically vastly outweigh the costs. And so I think all teams are basically moving towards a zkVM based model.
Okay, let's talk about the prover network in a little bit more detail. So kind of like in order to kind of become a prover, I kind of need specialized hardware. I get that because kind of like you're gearing this towards GPUs. What else do I need to fulfill to kind of become part of the prover network? And how do you make sure that the prover network remains decentralized and incentivized effectively?
Yeah, it's so for the prover network, as you mentioned today, people need like GPUs to join and run proofs. And again, our prover network, like we've written up a design for it and we're gonna be publishing that soon. And we'll probably have like a test net in the upcoming months for it. And so we'll be able to like test out a lot of these ideas and make sure that they actually work. The mechanism we designed for the prover network in terms of allocating who gets what proof and stuff like that was specially designed to keep decentralization in mind. So normally you could to decide who gets a proof, you could allocate it to, the person who offers to prove it the cheapest. Or you could have some mechanism like this that's kind of a straw man. Our mechanism is specially designed so that it still maintains decentralization and prevents like prover concentration. So more concretely, there's kind of this parameter that you can tune up or down. And depending on what the value of that parameter is, sometimes with some probability, people who are a little more expensive than the cheapest prover will still get selected to generate a proof. And that's like important for making sure that a lot of people can participate and it just doesn't concentrate towards like one really big, large, dominant prover. So yeah, we kept that pretty explicitly in mind when designing the mechanism for the prover network. Yeah, that's probably the biggest important thing for it.
This is a very noob question, but is the output of the zkVM deterministic? So kind of like if I put in some sort of Rust code, will I always get the same output?
Yes. Or people should only prove programs that are deterministic. So yes, that's true.
Okay, so I can easily verify that kind of the code that I'm getting back from the prover network is sufficient and correct, right?
Yeah. The whole kind of point of ZK is that you can verify that the proof and the computation was done correctly in much less time to redo the computation. So I think that uniquely enables the prover network. There's like no additional trust assumptions. There's no, there's no additional like trust vectors. You send it your request for a proof, someone generates a proof, and then you can verify that the proof is valid, and then the money gets like sent out to them after the proof gets verified.
So I assume Succinct's business model is also somewhere in this incentive layer, right?
Yeah, that's exactly right. I think our thesis is that people will want to use the prover network because it'll be much more cheap and much more efficient and much more easy than them setting up their own infrastructure. I think in practice, people that use SP1 today use our cloud proving service instead of running it themselves. We basically offer like a we like to call it our prover network beta, but really it's just us generating proofs and sending them back to people. And most people use SP1 through that because setting up your own infrastructure really sucks. So we imagine that, people want to generate proofs and pay for that. And that those fees will be directed to the prover network. I kind of imagine it actually similar to DA, where today, like if you're a rollup, you pay Ethereum for settlement, you pay Ethereum for DA because you're posting your transactions there. And I imagine in the future that part of each transaction will pay for proving, and that will go towards our prover network.
When you say that goes towards the prover network, you yourselves, are you a privileged party in that prover network? Kind of, do you get kind of some basis points of all transactions that are kind of settled on that prover network? Or are you just one of the provers yourselves?
Oh, like our company?
Yeah.
No, I don't think we'll be a privileged party. Like it's going to be a decentralized, neutral protocol, and we will just participate in it. Probably as like a prover of last resort, basically.
How does it work for you in business terms, though? So kind of like if you're only a proving participant in your network and you get the fees that everyone else who hasn't developed either SP1 or the prover network also gets, how is that worthwhile for you guys?
Yeah, well, I think the network will also have some like marketplace fee for, facilitating kind of this interaction. Yeah.
Okay. So that way kind of you are kind of, your company somehow is a privileged party, and that kind of like you're offering the marketplace, and kind of like I kind of, if you're working under the assumption that kind of like these ZK proofs will be commoditized completely, then obviously kind of the fees will be kind of like a race to the bottom. So you need to be able to kind of participate in kind of like the entire volume and to kind of make it worth your while, right?
Yeah, exactly. Like I think it's like any other protocol. For example, Lido kind of facilitates this interaction between people who want to stake and then also like the professional node operators, and they have a 5% fee to the node operators, 5% fee to their protocol. I imagine it being pretty similar.
Okay. So what blockchain applications are currently supported by your offering? So you just talked about the OP Succinct offering. Is there anything else or anything you're particularly excited that's launching soon?
Yeah, so 2 bridges actually run on SP1. The Celestia bridge and the Avail bridge are like SP1 programs, and run through SP1 and, our ZK Byte clients actually on Ethereum that, secure pretty big ecosystem. Our original dream of every bridge being a ZK bridge came true, but it is through SP1 instead of, our original approach of handwriting every single program. So that's pretty cool to see. I'm very excited about the zk-rollups and OP Succinct. They're a very popular rollup stack. A lot of people use them, like Base, Unichain, World Chain as well. So it's kind of exciting to one day have a path towards all those ecosystems becoming ZK rollup. There's also a lot of other people building very cool stuff. Some in the Bitcoin ecosystem, they're building like Bitcoin rollups or Bitcoin L2s, some Bitcoin bridging. There's even some people in Solana that are building with ZK with their new network extensions. That's also quite interesting. There's all these application-specific blockchains also for like trading that I think are quite interesting. Basically, I have this thesis that in the long term, for very, very popular apps like trading, it doesn't make sense to have the overhead of a general purpose execution layer. You're going to have these like specialized rollups that are only built for one application and are hyper optimized for it. And some people are building basically these like decentralized exchanges that are hyper optimized for trading with SP1. So that's also another cool kind of category. And then there's stuff outside of blockchain like ZK email. Someone made this proof of driver's license application with SP1 that was cool. Like you verify your driver's license and you can reveal information about that with a ZK proof. So that ZK identity stuff is also really interesting to me.
Yeah, super interesting. What do you see as kind of the main bottlenecks in ZK adoption?
I think right now with SP1, ZK is actually finally really easy. Like in a lot of the protocols we talk to and work with, for them, using SP1 is often the simplest part. It's really building out the rest of their protocol that's hard. Building the on-chain smart contracts, even designing your protocol logic, building out the front end, stuff like that. So I think there's this new generation of like ZK native protocols that are building with ZK from day one. And actually, ZK is the easiest part. And getting their entire protocol to mainnet is kind of like the biggest blocker to them wanting a lot of proofs. I also think there's some like kind of technical debt and emotional attachment to the old way of doing things in the ecosystems as well. So, for example, I think tomorrow every rollup should be a ZK rollup, and all the OP stack chains should immediately use ZK because it's cheap, it's really fast, it works. But I think for a lot of people, like they're used to the optimistic technology, or in many cases, they don't even run fault proofs at all. So they're just using a multi-sig, and that's kind of easy enough. While things are good, obviously it's really bad when something breaks, but that happens rarely. So I think ZK is kind of like, it's kind of similar to decentralization in a way. It's like eating your vegetables. Like you kind of have to, decentralization is really important when something goes wrong or there's, some like breakdown in trust of the centralized actors. And that's when people are happy they built a decentralized system, right? So I think ZK is similar where it's like, oh, maybe using the multi-sig is fine 99% of the time, but then there's this catastrophic tail risk. And you really wish you actually did have full validity proofs in those situations. And so I think as an ecosystem, one of the biggest things today is like we're all just, kind of living in the happy path and living in this world where we don't worry about those scenarios. And I think in general, there needs to be like more of a push to like actually having decentralized, verifiable systems that operate, that actually kind of fulfill like the promise of all the stuff that we're doing.
Yeah, no, I agree. I think people don't like thinking about the failure modes kind of as long as things are good, right?
Yeah, they don't think about the failure modes until it's like too late.
Yeah, absolutely. What kind of metrics do you look at for Succinct to gauge your success? So kind of like what are you optimizing towards?
I think one really concrete metric is just number of proofs and also like, amount of computation. So we call it like cycles, like how many RISC-V instructions are we proving? So that's a really fun metric to look at. I think recently, like in the past month, we proved like trillions of cycles. And that's been going up and to the right very quickly, especially as we get more and more rollups using it because they use a lot of cycles. The other metric I think I personally care a lot about is like kind of like the quality of the usage. So it's like, are we meaningfully moving the ecosystem towards more verifiable systems and like, um, you know, more verifiable applications in general? So for me, OP Succinct was really exciting because it was like an opportunity where you can now finally see a path for every rollup on Ethereum to be a ZK rollup. And even though that doesn't happen like today, it's kind of like the first step, and then you can fill in the dots. So yeah, that's like another metric. It's like, oh, like, can this thing be generalized to like n more instances?
So SP1 is open source, right?
Yeah.
So as a proof of network, what's your moat? Kind of like what stops me from kind of just setting up a second prover network that kind of just make sure there's a kind of fee race to the bottom?
Yeah, that's a good question. I think integrating with a prover network, there's like a developer integration cost and developer switching cost. And then also, like, all the provers will be connected to our network and generating proofs with our network. And so, if you want to access kind of all the provers in our network, then and you there becomes another competing network, then you're not going to like want to switch over. So, I think the network itself kind of aggregates both the supply side, so like all the provers, and then also all the demand side, which is like all the proof requests. And then with that, there becomes this like flywheel that's like, the more demand there is, then the more supply gets built out. And then the more supply that gets built out, proofs get cheaper. So hopefully there's more demand. And so I think it would be really difficult for another prover network, I think, to come in and compete and like make sure all the provers are integrated and make sure all the demand also gets routed there and stuff like that.
Which way do you see Succinct developing? So kind of like if you think about kind of Succinct in the next, say, 3 to 5 years or so something inordinately long, kind of like in blockchain terms. Um, where are you going?
I think for us, like, we just want ZK to be as widely adopted as possible and making, as many things verifiable as possible. I think verifiability is this like very fundamental new primitive. And obviously, in the context of blockchains, it's very powerful and needed because mm, that's like one of the fundamental premises is that you're building these like verifiable, trustless systems. And so for systems to be trustless, they have to be verifiable. So I think it's very fundamental to blockchains. So I really hope it gets adopted in all the blockchain contexts that it should be. So that's like rollups, bridges, stuff like that. But then, yeah, beyond that, I think I'm also really excited about seeing these verifiable systems more in the real world as well, beyond blockchains. And I think that will be very, very interesting. And I think that's uniquely kind of enabled by being able to write normal code. Like, I think it's hard to imagine that normal people adopting this ZK stuff if they had to go through all the pain of writing custom circuits and doing all this cryptography and stuff like that. But now that you can just take normal Rust code and generate proofs of it, hopefully that enables a much larger class of applications to become verifiable.
What new features or improvements can we expect? Or is it, I mean, I assume kind of the stack's not ossified, right? Kind of like it'll keep developing.
Yeah. We're always trying to make it faster and cheaper. So that's like our main series of improvements is on the proof system side, kind of innovating and figuring out how to make the underlying cryptography better. Also on the engineering side, there's a lot more optimizations that we're always working on to make it faster and cheaper. So yeah, on the SB1 side, that's like our North Star is to make it as fast and as cheap as possible. And then I think a really big upgrade will be finally having an actual prover network where anyone in the world can participate in generating proofs. And hopefully that also enables SP1 to get better and better as well, because now it's not just us generating proofs, it's like harnessing humanity's collective intelligence and optimizing the system. So I kind of view it similar to like mining, where in Bitcoin mining, you had this proof of work game or proof of work puzzle, and there became this global scale hardware build out centered around it, right? You had so many mining companies that were developing, their custom ASICs and then also deploying it in data centers across the world. And it became this like global movement to optimize computing a SHA hash function. And our hope is kind of like by having this prover network and also setting up this very similar game and objective that, it'll be like this collective global race to also improve SP1.
If kind of SP1 and ZK tech kind of gets integrated into other tech that kind of like you're hoping it will get integrated to. How will the internet be different in 5 or 10 years from now to how it is today?
Yeah, I think today, like, if you want verifiability on the internet, there's two options. One is you transact with like a decentralized system like Ethereum or something like this, right? You have this very expensive, like decentralized consensus. Or you have regulation. So for example, like if I want to get a credit score, there's a credit scoring agency that is responsible for, computing my credit score based on a bunch of statistics. And then they're regulated by the government to make sure that they're like not doing anything racist or bad. And then, yeah, we just have trust and verifiability through basically regulation or trusting centralized intermediaries. So I think in a world where verifiability is like very easy and very ubiquitous, you could imagine instead that the same credit scoring company instead has to post a ZK proof that they updated everyone's scores in a correct way, according to a fair model that we all agree on is like the correct model. And instead of having regulation, you basically verify a cryptographic computation and you can make sure that people are doing the correct things and like, respecting the properties you might want of their systems. So I think that's pretty exciting. You can just have verifiability in a lot more places and you can have it enforced with code instead of with like regulations.
So kind of like if you look at metrics that pertain to the average user, how would they notice that?
Yeah, that's a good question. I guess in this credit scoring example, I think they would probably notice systems becoming like more transparent. So you have just like more transparency on like what's actually going on in like all these currently regulated entities. And right now you're like trusting that the government does a reasonable job regulating, but in the future you can check yourself. So I think you just get a lot more transparency. And then I think if you have more verifiability, then it should also be a lot more efficient, right? Because and I think that's also like one of the theses of like crypto broadly, right? Is like, okay, now we can have this like trustless exchange. And now we can have like trustless exchange of like any asset. And that's kind of what lets us have like all the millions of assets we trade today on chain, like all the meme coins and like NFTs and stuff like that. And so you can imagine that like, oh, now that verifiability is really easy, maybe we have more expressive conditions that we can use in our day-to-day lives, if that makes sense. I mean, I guess this is a bit abstract, but I think you just have more expressivity and then that leads to more efficiency because you can just like do more complex stuff.
So tell us about the timeline for the prover network. When is the test net going to come live? How can people find out more about it? How can they be prepared to kind of take part as provers?
I think the kind of architecture and design will be out in like the next few weeks. And then after that, the test set will probably be out in like the next few months. We already have like an internal version working that we're testing out. So maybe we have like a dev net internally that we use, but yeah, the test net that's like people can participate in a full form, I'd be out in like the next few months.
And how do people stay abreast of developments? Kind of where should they follow you on Twitter or where do we send them?
Yeah, Twitter's great. Just the Succinct Labs account or my personal account is also a good resource.
Cool. Fantastic, Uma. Thank you so much for coming on today and telling us about the Prover Network and SP1. It's been a pleasure.
Yeah, thanks for having me.